Hello everyone, today we are going to start electromagnetic waves. First of all, the scientist who has the greatest contribution towards electromagnetic waves is Maxwell. It is due to his experiments and research that laws of electricity and magnetism were unified. James Maxwell was also responsible for declaring that light waves are also a part of electromagnetic radiation. What was the greatest achievement of Maxwell? We have already studied that. That is the production or the discovery of displacement current. This was the experiment we studied about while doing the derivation for displacement current, that whatever the expression, what was the expression? B dot dl was equal to mu naught I. This equation was not consistent for the place where electric fields were changing, right? So this equation was consistent only for the place of conduction current, that is this much part, but where there was a changing electric current and hence changing electric field and hence a changing magnetic field, there was displacement current and there was formula derived for it, which was this one, right? Mu naught epsilon naught d phi by dt. This epsilon naught d phi by dt is the value of displacement current. Let's revise these equations which I have already studied. First of all, E dot ds is equal to q upon epsilon naught, that the Gauss theorem. What was Gauss? Statement that total flux is what? Total number of lines which are coming out of a closed space. For example, this is a closed sphere where we have placed a charge q. So total flux means total number of electric lines of force which will be passing out of this closed surface will be equal to flux, which is actually that E dot ds, E ds cos theta, that will be equal to 1 upon epsilon naught times total charge enclosed in it, that means q upon epsilon naught, right? This is something which we already know. Now, if I would like to change it, for example, instead of single q, I am placing plus 2q minus 3q plus 4q and minus 1q, or it would be actually minus q. So the net flux which is coming out of the closed surface is due to what charge? It will be due to the sum of the charges, that is plus 4 plus 2 is plus 6, 6 minus 4 is 2. So the net flux is due to plus 2q, right? That means if there is another minus 2q here, so total flux would be equal to 0, right? Because there is no charge inside it. That is why Gauss law for magnetism is B dot ds, which is equal to 0. Why? In magnetism, we never have monopoles, we always have two poles, that is north and south. So whatever lines which are coming out of one pole will be coming inside the other pole, or in other terms, the pole strength of one monopole, that is north pole, will be equal to the pole strength of the south pole, but opposite in sign. So that is why, since monopoles doesn't exist, same as the case as we if I write the Gauss theorem for a dipole, so net flux would be equal to 0 because there is net charge inside is 0. Similarly, net pole strength inside or for a magnet is 0. That is why Gauss theorem for magnetic field, this one would be 0. Then we have done it in electromagnetic induction that that rate of change of flux is equal to induced EMF produced in the body, and there were Faraday's laws of electromagnetic induction. There were few laws. One was that whenever flux linked with the circuit and induced EMF is, whenever flux linked with the circuit changes and induced EMF is produced in it, and induced EMF lasts so long as the change in flux continues. Number 2 was rate of change of flux will decide the magnitude of induced EMF produced in it, right? So we have studied these laws before. Now there is another scientist, without his mention we cannot proceed in electromagnetic waves, that was Hertz. So Hertz experiment, we have this in our syllabus, Hertz experiment. So this Heinrich Hertz was the first scientist who actually transferred and received radio waves for a long distance. He was also the first scientist to produce that oscillating charge, or that is oscillating charge through spark. He produced spark, will do it in his experiment. Oscillating spark produces electromagnetic waves, that means they are source of electromagnetic waves. For example, the Hertz experiment was like this. He had two spherical conductors which were given very high potential difference. Due to very high potential difference, what will happen? The air between them will get ionized, right? High potential Air has a breaking potential value of what? 10 raised to power 6 volts. So this value, this air will get ionized, and the charge from each body will leak from the air and spark will get produced. This spark or oscillating charge are the source of electromagnetic waves which was detected by the detector. This was Hertz's experiment, and most important thing in this is why Hertz's experiment is famous. Hertz's experiment is famous because Hertz was the first scientist who proved that oscillating charge, that is sparks, are source of electromagnetic waves. Now, how and what are electromagnetic waves? First of all, how electromagnetic waves propagate. Electromagnetic waves are actually transverse in nature, and electromagnetic, the term itself describes that it has both electric and magnetic field. So if I have XYZ plane like this, okay, so I will be having electric field. If we are having electric field towards x-axis, then magnetic field will be towards or perpendicular to it, either ZY axis or Y or any other axis. Right now I have taken XY axis for the propagation of X-rays, then YZ axis for the propagation of the magnetic waves. So basically this is how you would be representing these waves in your notebooks, that electromagnetic waves are transverse in nature, where both electric and magnetic field propagate in perpendicular directions with each other. This is a simple diagram to represent that, right? Now, we already know about the terms wavelength and frequency. What are wavelength? The distance between two consecutive crusts or two consecutive troughs are wavelength, both the case. And what is the relation between wavelength and frequency? Speed is wavelength into frequency. C is equal to nu lambda. So if you have wavelength, you can calculate frequency by C upon lambda. This is the formula. Now, one important thing is that in chemistry, there is this equation which you have learned about a lot in chemistry, which is energy, E is equal to h nu. This energy is associated with frequency of particle. So basically small particles, basically what? Photons. Photons are what? Photons are particle or wave in nature. Photons have dual nature. We have already proved it. We are going to study this as well again in dual nature of matter radiation. But anyhow, particles like photons have very high frequency, and energy is calculated using this formula. So basically energy is a direct function of frequency, right? So if frequency is large, that means it has a very large energy or very high energy. So we are going to study a lot of different properties associated with electromagnetic waves, not directly, but indirectly by studying various natures associated with them. For example, what is the connection between light and microwaves and X-rays? They are all part of electromagnetic spectrum. Alright. So when the wave, an electromagnetic wave travel from one part to another, what happens? How do they interact with matter? Do they transfer their energy or not? That entirely depends on the nature of wave traveling and the matter on which they are striking, right? So let's move on. Electromagnetic radiation that travels as wave and transfer energy from one place to another. Electromagnetic waves are transverse waves made up of both electric and magnetic field, which we have already discussed. All electromagnetic waves travel at the same speed, which is what? Speed of light, 3 into 10 raised to power 8 meter per second, right? Now, different electromagnetic waves can respond in different ways to different matter. That basically depends on the nature of medium when they are getting contact with. For example, microwaves carry less energy than X-rays, but we still use microwave for heating a food, not X-rays. We use X-rays to do what? To measure bone density, because X-rays do not get, they interact with the bones, the denser molecules, they just pass through the skin molecules, right? So amount of energy carried by an electromagnetic wave depends on what? Wavelength. See, energy is a direct function of frequency. So indirectly, energy is inversely proportional to wavelength. So what you can say is, higher the wavelength, lesser will be the frequency and lesser will be the energy. Lower the wavelength, maximum will be the frequency and maximum will be the energy, more will be the energy. Now, one more thing, both of these statements are interlinked. Wavelength and frequency are linked properties, and we have described both these statements, right? Now, there was this a picture of microwave oven. Have you ever wondered how microwaves work? See, I'll explain. To understand how microwave works or it heats up our food, for that you first have to understand how heating works. Suppose if you have a lighter right now and take any plastic body, for example this sketch pen, take a ruler, any plastic body, because heating effect is visibly very fast in plastic bodies. You heat it up. This is the symbol of heat. This is a scale or ruler made up of whatever molecules or atoms it is made up of, right? I am heating it up. What happens during heating? What is the process involved? If you have this plastic scale or this sketch pen which I am heating up, the surface will start melting. Why melting? Why it is changing its form? What exactly is happening when heat is getting transferred to this body? See, for that you have to understand the fact that this energy is actually absorbed by these atoms or molecules which are already in a state of random motion, that is thermal agitation energy. This energy is associated with every atom present in every matter which is surrounding us, and this thermal agitation energy, that is even at room temperature, atoms and molecules gain enough energy so that they can vibrate about their mean position. Now, when you are giving this heat to this body, more and more number of atoms are getting more energy, due to which they are vibrating more vigorously about their mean position. So in a way, the mean distance between these two atoms is increasing, right? Basically, the bond formation between two atoms is a condition that both of them lack some part of energy and they are associated with each other. But when both of them are getting the same amount of energy from an outside source, they do not want to be in bond with each other. That is, they are breaking their bond, and that is when the solid changes its form. That is the basic difference which we have studied in lower junior classes, that in solids, atoms and molecules are very compact or closely packed. In gases and in liquids, distance is a bit larger, and gases, they are very loosely packed. So same ways, this molecule has gained the energy. It does not anymore require the bond formation with any other neighboring atom, and it will break free. Breaking free, that is what we are calling it changing its state. So in a way, the heating effect, what does it actually gives energy to atoms and molecules, and they start vibrating about their mean position very vigorously. So in food particles, we have, what do we have? When we place our food in tiffin and we place it in microwave, what happens? Food has moisture or water content in it, right? Water molecules, if they are given energy from microwaves, so they start vibrating about at this frequency 3 gigahertz, that is 3 crore times per second. So this is the actual vibration when you boil a water. When you take a beaker of water and you make it boil. So while boiling water, the molecule is vibrating with this frequency. Same thing happens when microwaves of particular frequency, set frequency, are exposed on water molecules, right? So food particles already have moisture or water molecules on it, inside it, and when they are exposed to microwaves, these atom molecules, they start vibrating with this much frequency, and basically they are getting heated up, and they actually heat up the surrounding, that is the neighboring food particles. This is how the whole food gets heated up. But why the container which is containing it is not getting heated up? For example, if I put the food, we are all being given this instruction that don't keep the food in metallic bodies and keep it in microwave ovens. Why? Because smaller the particle, more will be the frequency of vibration. More will be the frequency of vibration, that means more will be the heat produced in it. So if I place the food in metal bodies, the metal body atoms and molecules which are very closely packed and smaller in size, they'll get heated up very fast. The metal can melt, it can damage your whole thing, the microwave, and in fact it can do one more thing, the charge can get accumulated on the metal body, due to which we can get shocked. So we keep the food in porcelain containers or plastic containers, not the simple plastic but the fabricated plastic ones which we use these days, which are called microwavable containers. So these fabricated plastic or the porcelain containers, they have very high, their atoms or molecule size are very bigger as compared to the normal metal or plastic body. So even they start vibrating by gaining energy from microwave, but their frequency of vibration is not as large because of their very large size, and hence they do not get heated up. So that is why we are advised that we have to keep our food in porcelain containers or plastic, that fabricated plastic or microwavable containers, right? Next, when electromagnetic waves hit a surface, they can be either reflected, absorbed, or what? Can they be absorbed by the body? All electromagnetic waves have some sort of energy, either less or more, but they have energy. So if they are absorbed by the body, will there be a negative effect on the body? For example, I am using my cell phone. I am talking to one of my friends for a very long time. These cell phones, again, they are also operated on microwave frequencies. Now, microwave have energy. So that energy is being exposed on my ear, head, everywhere for a very long time. So that does mean it has a negative effect on my health. This is not yet proved, but yes, they can heat up the temperature of our mind by 0.2 degrees Celsius after use of more than 20 hours. This has already been proved that yes, they can increase the temperature, but negative effect as such not has been discovered. So how the waves behaves depends on their energy and type of material in which they contact. For example, this visible light are reflected by the skin, but X-rays, they easily pass through the skin, but they are reflected from the bones, that is denser molecules, right? If electromagnetic waves are absorbed, some of their energy is absorbed by the matter in which they are contact with. Some surfaces can reflect electromagnetic waves very well. For example, shiny surfaces, mirrors, dishes. What do dishes do? Not that dishes which we use in kitchen, the dish antennas which we use at our roof to transfer or to absorb the signals for watching television. These dishes are made parabolic in shape because they are supposed to reflect all the waves which are incident on them towards the transponder. So when waves are reflected, some of their energy may be absorbed by the material, which this we have already discussed. Curved satellite dish reflects microwaves from satellite to the receiver. We have just done that. Now, this is our electromagnetic spectrum. These are all the various different type or different parts of electromagnetic radiation. This having the lowest frequency, this being the maximum frequency. Number 2, having maximum wavelength and minimum wavelength. So because they are inversely proportional to each other, right? So depending on their wavelength size and frequency size, there will be the energy, right? So as it increases in frequency, the energy will increase and hence its hazard issues will increase, right? Because high frequency means very high energy. So what can they do? Okay, what we are doing right now is we are trying to understand some part of electromagnetic spectrum by their behavior, and again we are going to study some more properties. All right.